Hi, hello, dear students. Welcome to solid state. Next lecture, third lecture on space lattice or crystal lattice, followed by unit cell and its informations. Just carefully observe. Crystal lattice is a word we are using, or space lattice word we are using, which is the most important fundamental information required for the study of solid state. But in this, how can we understand the crystal lattice? Anybody asked. What do you mean by crystal lattice or space lattice? Anybody ask. Then start giving information by considering the constant particles. Constant particles means atoms, ions or molecules are there in solids. Actually, they will make up the crystal, and these constant particles in these solids are said to be arranged in a regular repeating pattern. They will arrange regular repeating pattern, and that regular repeating pattern of constant particles relative to one another, how they arranged three-dimensionally, which is known as space lattice. It is a little complicated one. When we are talking about space lattice or crystal lattice, it is nothing but an infinite set of this type of points or lattice points or constant particles. Arrangement is known as space lattice. So what is space lattice? The arrangement of infinite set of points, means lattice points means atoms, ions or molecules. One point means their possibility of ion or atom or molecule is there, right? That kind of points is known as, this arrangement is known as space lattice. So arrangement of infinite set of points three-dimensionally, points in space, we can say three-dimensionally. In space is known as space lattice or crystal lattice. So when you are drawing any kind of picture like this is a point, this is another point, this is another point, this is another point, like this. Repetition, if they are repeated like this, and that infinite set of points arrangement three-dimensionally in the crystal is known as crystal lattice. For example, in this kind of space lattice or crystal lattice, the pattern of points describes the arrangement or geometry of the crystal, which is also called as space lattice. So space lattice can be defined in different manner. The positions occupied by these atoms indicated like this. These are points. Okay, and this is nothing but a lattice point or lattice site, point or site in the study of crystals. Okay, So this type of set of points repeated in regular intervals along a line. If you take a line in one dimensional, you can take, okay, a set of repetitions in two dimension also you can take, three dimension also you can take. So a three dimensional arrangement is called as space lattice. In one line you can see, in two lines you can see. So that arrangement is there, whatever the arrangement is there, that set of arrangements, three dimensional arrangement is known as a space lattice. Suppose when you are observing points like this, so if you write like a cube, if you are writing, okay, like this, okay, so if you join the points like this, here one, join the points like this. So now imagine if there are some points are present here, one, here and here, and this kind of repetition, whatever repetition is there, right? Now you are going to write some cubes also. Here you can observe a cube, here you can observe one cube, here you can observe one cube. So if you write here also some points, in joining them, you will get much more complicated one, like this, here, like this. Now if you observe one particular cube here by noticing a three-dimensional portion. So in this, if you just notice a three-dimensional portion, still you need to connect here and here, okay, like this. So here if you observe one portion from towards your side, I will just apply shade to this one. You observe this one. So take it outside, then how it looks like. That is also like a three-dimensional one. So this is the portion, like a cube. Okay. So what do you mean by this one is nothing but repetition. So whatever repetition is there, the repetition in the arrangement of this kind of three-dimensional arrangement of points is there, that we can call it as space lattice. Now coming to the point, when you are talking about this type of information, okay, a small portion, shaded portion is there, a small portion, three-dimensional, and that small three-dimensional portion also you can call unit cell. That is called as unit cell. So what is a unit cell? In this crystal lattice, if you imagine some points where a large number of small units are there, the large number of such kind of small units repeated in crystal lattice also called as unit cells. So the repeated three-dimensional arrangement of the points in a crystal lattice is called as unit cell. And this infinite set of points three-dimensional arrangement is called as space lattice. So almost there is a very much close information is there, but a small portion in the crystal lattice or space lattice is called as unit cell. That unit cell is a three-dimensional repeating unit in the crystal that decides the geometry of the crystal. So that is the information you need to understand. Not only this one, unit cell is nothing but a smallest repeating unit in crystal lattice. So whenever if they are asking what is the definition, that is smallest portion repeating. Again you can write three-dimensional. Here only you can write three-dimensional portion repeating in crystal lattice. So that is called as unit cell. So now you are in a position to understand what is unit cell. Once again I will repeat the definition of unit cell. That is, unit cell is the smallest portion of crystal lattice. Actually it is a three-dimensional one. When you represent different directions, these different directions are there for this one, x direction, y direction, z direction is there, then the geometry of the entire crystal also definitely gets changed accordingly on the basis of the unit cell's directions. So unit cell definitely is most important one in our discussion, that unit cell is nothing but smallest three-dimensional repeating unit in the crystal lattice is called as unit cell. Hope you understand what is unit cell. I will write big diagram now once again to continue with this. Okay, hope you understand this information, right? Now move on to the details of this unit cell, the smallest portion of this crystal lattice, that is unit cell, we will see. Okay, now talking about this unit cell, lot of ideas definitely will come across in this study of solid states, right? The conditions how to choose unit cell are most important in the crystal lattice. So unit cell possess same symmetry as the crystal. So how the crystal is there, unit cell also symmetry should be same. If there is a choice between two or more repeating units, the one which has smallest number of points is chosen as unit cell. So there is a condition is there. How to choose the unit cell in the crystal lattice? How to choose the unit cell in the crystal lattice is nothing but, in a crystal lattice, when you are observing a repeating unit with the smallest number of points, lattice points, that is considered as unit cell. Maybe two or more choices are there you have in the crystal lattice, but which is a three-dimensional smallest portion made up of lattice points is there, that is called as a unit cell. That decides the geometry of the crystal. Crystal symmetry and unit cell symmetry should be same. And we have told that there are so many geometries are there, square, rectangular, as well as parallelogram. These are lattices are there, and these lattices are unit cells normally chosen in that square is normally chosen. So that we can understand in this way. Okay. So now I am just writing directions of axis. So if I take, this is x-axis, this is y-axis, this is z-axis. Now the information definitely gets started. That is, the dimensions along the three edges are there in the unit cells. Okay, that are also important in our study. And what are those dimensions? What are those axes? What are the angles we will see? Characteristics of unit cells are most important in this kind of unit cell discussion. If you take, this is the side A. The other one you can consider as B. This is B. This is C. This is A. This is B. This is C. Angle made by B and C. B and C you can consider that is alpha. And between A and B, consider that is gamma. B and A and C, that is beta. Okay, like this you can observe that entire fundamental of elementary pattern of crystalline solid characterized by the distances. The distances A, B, C are the distances, and alpha, beta, gamma are the actual identical you can say angles, interfacial angles of this cube. So A, B, C are distances. Alpha, beta, gamma are interfacial angles. They are called interfacial angles. So in this three-dimensional arrangement, along three angles are there, alpha, beta, gamma. The edges are there or distances are there, A, B, C are there, and these all will decide the geometry of this unit cell. That means, how can we understand the characteristic parameters of the unit cells? Means the first you have to talk about the crystallographic axis. What are crystallographic axis? X, Y, Z axis. So the lines drawn parallel to the intersection of any three faces of unit cell are there, actually which do not lie in the same plane, which are called as crystallographic axis. For example, if you just observe this line or A line, this line is parallel to x-axis. This is parallel to x-axis. Okay, what is the meaning of this one? Which do not lie in the same plane, which is called as crystallographic axis. This is not present in the same plane. That is the meaning of crystallographic axis. So line drawn parallel to the lines of intersection of any three faces of the unit cell. Of any three faces of the unit cell. This is one face, this is one face, this is one face. Okay. So in such a case, the unit cell which do not lie in the same plane, which is called as crystallographic axis. So we have to observe carefully these crystallographic axis under study. The other one is interfacial angles. We call these are interfacial angles. That means these are the angles between the three crystallographic axes. Angle between the crystallographic axis X, Y, Z. So angle between crystallographic axis nothing but A, B. Angle between A, C. Angle between B, C. So angle between B and C. Angle between B and C is nothing but alpha. Angle between A and C nothing but beta. Angle between A and B is nothing but gamma. So these alpha, beta, gamma are said to be interfacial angles, and these angles are nothing but interfacial angles, angle between the crystallographic axis. Okay. The other one is nothing but talking about one important word here, that is primitives. Primitives. And this point is nothing but O. Assume this is the origin, midpoint. Okay. And we are talking about one important point here, the three sides. What are three sides? Distances or sides, also called as sides. A, B, C are there. And these three sides of unit cells are known as primitives or characteristic intercepts. These are nothing but characteristic intercepts. A, B, C are. A, B, C are characteristic intercepts. Okay. And crystallographic axis. What are crystallographic axis? Now you can see OX. OX. That is one from this picture. The other one is OY. OZ. You take OX crystallographic axis, OY crystallographic axis, OZ crystallographic axis. What are the angles? Okay, if you take angles alpha, beta, gamma, these are the angles. So A, B, C are primitives, and OX, OY, OZ are the crystallographic axis. Alpha, beta, gamma are angles. Okay. And A, B, C are the primitives. A, B, C are primitives. Okay. They are the important terminology used in the study of this space lattice unit cell concept. Okay. Now talking about unit cell, in this the dimensions along the three edges. What are the edges? A, B, C, and edges may or may not be perpendicular to each other. So mutually they may be perpendicular in most cases. They may not be perpendicular in some cases. The another point here is very clear that angles between the edges, alpha is found to be the angle between B and C. Alpha is found to be the angle between B and C. And what is beta? Beta is between A and C. And what is gamma? Gamma is the angle between the A and B. What are the A, B and all? These are edges of this unit cell. Okay, alpha, beta, gamma. Study. Now, these parameters definitely shown in the unit cell decides unit cells classification. Unit cells classification. Okay, that we are going to now observe. Okay. Let us talk about such kind of unit cell and their informations. Now, I am going to speak about primitive and centered unit cells now. Primitive and centered unit cells. Primitive and centered unit cells. Talking about primitive unit cells, first we are going to talk about primitive unit cells. Primitive unit cells. What is the meaning of this primitive unit cell? Nothing but usually what we do is we will imagine a cube, right? In the cube, if you imagine where the lattice points are present in this primitive asked, then immediately your answer will be nothing but constant particles are present only on the corner positions of the unit cell. That is called as primitive. So, points are constituent points, particles present at corners. Corners. What is the meaning of that one is nothing but here if you observe a cube like this, unit cell, okay, and in this case you need to imagine here one, yeah, here imagine points at corners only. Only at corners if it is there, that you will call it as primitive unit cell. What is primitive unit cell? Primitive unit cell is nothing but the points, lattice points or particles present only at the corners, which is called as primitive unit cell, or simple cubic is also called as simple cubic. Simple cubic unit cell. Simple cubic unit cell. That is the meaning of the primitive unit cell. What is the meaning of primitive unit cell? Once again, observe primitive unit cell nothing but constant particles present at the corners. Like this. Comes the other one, centered unit cells. We have another one, that is centered unit cell. These are of different kinds are there. We have centered unit cells are there. In the centered unit cells, we have one is called as body centered. Body centered unit cell. Body centered unit cell. The other one is called as face centered unit cell. The other one, end centered unit cell. End centered unit cell. BCC, FCC, EC. So face centered, body centered unit cell, face centered unit cell, end centered unit cell. Like this. Three are there. First one, if you take, what is the body centered unit cell? First one, when you take the first one, lattice points are there like the primitive here also, but the point is nothing but we are highlighting one another point that is at the center of the cube. That means points are located at the corners as usual like the cube, like the primitive, but one point is present at the center of the unit cell, intersection of all the diagonals, whatever is there point, at that point there is one lattice point is present. Such kind of unit cells are called as body centered unit cells. So here, when I am just writing one point here, this is the intersection of all the diagonals of this cube, then this will called as BCC. That is called as BCC. So what is BCC? Once again I will repeat. Unit cell contains one constituent particle, that may be atom or molecule or ion, at its body center. So what is this one? This is nothing but body centered. Besides one that are at corners. So at corners we have points are there, and these all corners, 8 corners are there. How many corners are there? 8 corners are there. They will contribute 1 point, 1 lattice point. But here at the body center, that will belongs to entire unit cell. That is said to be belongs to entire cube or unit cell. That is the meaning of this. So how many portions of these corners are there? 8 corners are there, but they will contribute only 1 point. And body centered 1 point is there, that belongs to the entire unit cell in the BCC unit cell. This is called body centered. Why you are calling this is centered unit cell? Body centered. So this is the first kind. Second kind, if you observe, face centered. Face centered means when you have given in information like cube, when you are writing a cube, you can write like this. So when you are writing a cube like this, each and every face, if you assume 1 point, in addition to the corners you have already some participation is there. Here one. We are showing for our understanding, but the contribution of this particle at this corner is only 1/8, because only 1 point is made with the help of 8 corners. So 8 corners distributed by only 1 point and its part. In face parts we have a face center. This is called as face center. Face centered point. So face centered points are there. How many faces are there for this cube? 6 faces are there. And every face we have one point is there. That means constant particles. That is only shared with another one actually. The face centered point. Actually, it will contribute towards the unit cell as 1/2 only. For example, if you take a sphere like this, in this only half of that portion only is present here in this one. Okay, or you can write like this. So this is half of the portion only present on the face. So such unit cells contains one constant particle present at the center of the each face. So we are just saying one, but this is not one. We will come to know what is the contribution later on. The contribution also I am telling, that is 1/2. So for initial understanding, we can say that each face we have one point is there at the center, besides one that are at the corners. Besides that one are at the corners. So this is face centered. This is called as face centered unit cell. This also comes under centered unit cell. Centered unit cell. Second one. Coming to the third kind, end centered. In the end centered, what will happen? We have is that we will just select only 2 faces. We will select only 2 faces. Okay, so here one, in addition to the corner points. Corner we have 8 points are. So here I am just telling you these are the points we need to notice. Opposite faces, 2 opposite faces you have to select. And the 2 opposite faces, if you just see the face centers, then in addition to the corners, this is called as end centered unit cell. This is nothing but end centered unit cell. So once again, what is end centered unit cell? End centered unit cell is nothing but strictly the constant particles are present at the center of any 2 opposite faces. Besides the corners present in the unit cell. Besides the corners. Okay. So this is about the types of unit cells. So primitive or centered unit cells we have. This is classified into primitive is 1, body centered is another one, face centered is another one, end centered is another one. A total of 4 different kinds of 3-dimensional repeating units in the space lattice we observed. They are nothing but primitive, body centered, face centered, end centered. Okay. So these all important in the study. Now let us see a few examples, few informations related to the unit cells and what are the kinds of unit cells, how many kinds of unit cells they are present and all we will see. But before the study, we have to talk about possible 3-dimensional unit cells. There are 14 such kind of lattices noticed by Bravais. That's why we will call they are Bravais lattices. He is a French mathematician and he has given the possibilities like that. And in that possibilities, The entire crystal systems actually divided into 7 systems. Those 7 systems how they have given, and in the 7 systems, cubic crystal systems, what are the possible kinds of variations are there, and what are the axial angles, how they are present, interfacial angles or axial distances, how they are present, we will see as a tabular column now. So the thing is nothing but 7 primitive unit cells and their possible variations we will see in this tabular column. So before observing the tabular column, I will give you a very small idea about that formation of the writing of that tabular column now. Seven crystal systems What are the 7 crystal systems? I will give you one idea. If you just remember this point, that is nothing but cute or HMT. Cute or HMT. So it is cute or HMT. Remember that one. You will get one idea in this one. So if you have NCERT textbook, you just go through that one in the textbook. There's a table column is there. Remembering that one is also difficult. So anyway, I am not just disturbing the pattern present in the textbook. In the textbook, we have page number that is 8. Page number 8, they are given one table column. That is, what are 7 crystal systems are there. In this, what is my idea is CU, cute. In that, CU is nothing but cubic system. Cubic system. CU is nothing but cubic system. TE, tetragonal system. TE stands for tetragonal. Okay, I will write here the name of the crystal system. Crystal system, I will write here. Here I will write axial distances or lengths. Here I will write angles, axial angles or interfacial angles. So first in this session, I am going to just give you these informations only. Crystal system, CU stands for cubic. CU stands for cubic. TE stands for tetragonal. Tetragonal. OR stands for orthorhombic. OR stands for orthorhombic. 3 over. Okay. R. What is R? R stands for rhombohedral. 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 H stands for hexagonal. Hexagonal. M stands for monoclinic. And T stands for triclinic. Triclinic. Okay. Just see. Is it sufficient? The bottom side? Right. Clear. Now I am going to just write like this is a column. It's most important for the examination point of view. That's why I am giving importance in writing this table column. Even examples also again I will tell you later on. Now, axial distances are A, B, C. Axial angles, interfacial angles are alpha, beta, gamma relation. Okay, their relation, how the relation is there. If you see that table column given in the textbook, select from that cubic. Here you write all the angles, distances are equal. Okay. Here you write this here you write the alpha, beta, gamma all equals to 90 degrees. Okay. And tetragonal, when you take tetragonal, second one if you see tetragonal, just write A is equals to B not equals to C. Next when you are writing A not equal to B not equal to C, you will write. So here A not equal to B not equal to C, you will write. You can just observe orthorhombic what they given the textbook. NCERT. Rhombohedral. So again you start from here. A is equals to B is equals to C. Here A is equals to B is equal to C. Like this. When you are talking about hexagonal, you repeat this one here. Again that is A is equals to B not equals to C. And monoclinic, here again you can say easily A is not equals to B not equals to C. And last one, repeat the same only, that is A not equals to B not equals to C. You can check with the textbook you have given. Hexagonal, A is equals to B not equal to C is there. Monoclinic, we have A is not equals to B not equal to C is there. Triclinic, A not equal to B not equal to C is there. So in which cases we have such things are there? See, A, B, C all equal in rhombohedral and cubic only, and A, B, C not equal in orthorhombic, monoclinic, triclinic. And coming to the angles alpha, beta, gamma, they all 90 degrees in first three cases. First three cases means first case cubic, second case tetragonal, third case orthorhombic. Orthorhombic. So just continue writing alpha, beta, gamma all are 90 degrees. Alpha, beta, gamma 90 degrees. And remember one thing, hexagonal we have gamma is 120, rest of the others are 90. So here alpha, beta equals to 90 and gamma is equals to 120. Coming to the monoclinic case, and we have rhombohedral case. Okay, monoclinic and rhombohedral. Rhombohedral, if you see, this is rhombohedral. Rhombohedral, A, B, C all are equal. In this case, and monoclinic. Monoclinic we have beta not equals to 90. Rest others are 90. And rhombohedral we have gamma not equals to 90. Rest others are 90. So, what is rhombohedral? You can check what is rhombohedral. Rhombohedral we have alpha. Alpha is equals to beta is equals to 90 degrees. So, alpha is equals to beta is equals to 90. Gamma not equal to 90. And in this case, alpha is equals to gamma is equals to 90 and beta not equals to 90. In this case, which case? Monoclinic. And triclinic. When you see triclinic, all are not equal. So alpha not equals to beta not equals to gamma not equals to 90 degrees. Not equals to 90 degrees. So like this you can understand there is one idea only, but it's not a difficult one. Whatever existed that only I wrote. Cute or HMT. These letters only I have selected. Cute or HMT. Okay. Now come to the point. I will give you one more interesting point, interesting discussion, that is how many possible variations are there of these unit cells. So here I will write possible variations. Here I will write possible variations. Extension. In this, usually primitive we will indicate with the P letter, face centered F, body centered B, end centered E. Okay. So whenever you remember this 324 1121, that is enough. 324 1121 in this case. 3 is for cubic, means what are the three unit cells? The names are primitive, nothing but primitive, okay, body centered, face centered. Primitive, body centered, face centered, they will come here. So what is my idea is P stands for primitive, F stands for face centered, and B stands for body centered, and E stands for end centered. This is the idea. So in this is 1, this is 2, this is 3, this is 4. 4 different kinds are there. All 4 are there in the third one. Only 3 are there in the first one. This is the meaning. And 2 are there in the second. 2. What are the 2? In this order only you have to write P and F. P and F. So you can see tetragonal in the textbook. Tetragonal we have primitive and body center are there. Body center. Sorry. Body center are there. Second one B we wrote, na? Right. So this is the second one. This is third one. Like this. So PBF. PB. Next PBFE. PBFE. Why? Because the next number is 4. 4 means for orthorhombic, all are present. All the variations are present. In this year NEET examination 2021, they asked how many unit cells exist with the crystal systems exist with the body centered unit cells. Variations 3. That is the question which is asked in this year NEET examination. Rhombohedral. See here we wrote 1. 1 means that is P. Next we wrote 1. Hexagonal, that is P. Next we wrote monoclinic. Monoclinic means 2. What are the first 2? You can check with that. First 2. In this case, only little difficulty we have. Primitive and end centered exceptional here. And exceptional came here. So, these are just for remembrance. But how many are there? End centered are there. Present in this monoclinic. That is little exceptional. The last one again primitive. So here only we have exceptional. In this manner, if you construct the table and start practicing that one, you will get an idea what is the relation between A, B, C and alpha, beta, gamma, that type of question, definitely you can answer in the examination. Okay. I hope you will practice like this and you will remember this kinds of number of possible variations also. And next, generally hexagonal in most of the examinations or simple board examinations they used to ask in that gamma 120 remember, and orthorhombic and monoclinic, these words when you use the example sulfur is the best example, and cubic sodium chloride and zinc examples. We have zinc sulfide examples we can give. Triclinic potassium dichromate example you can remember, and monoclinic sulfur. Hexagonal graphite you can remember easily. So that examples again will be noticed in the next session, and we will have this idea. I hope you understand this construction of this table and how we have given a small idea about the remembrance of this 7 crystal systems, how the 14 types of Bravais lattices are arranged in this. So 14, what is the 14? The 14 number is nothing but these are the 14. So here 3 are there, here 2 are there, here 4 are there, here 1, here 1, here 1. Here 2 are there, here 1 is there. Total, we can just count 5 plus 4, 9, 9 plus 2, 11, 11 plus 3, 14. These are the 14 Bravais lattices arrangements in the 7 crystal systems given in this table column. So first we start this phase lattice and crystal lattice, and followed by unit cell definition and its information, and types of unit cells, primitive and centered unit cell classification. After that the definitions also we observed with pictures. Now the unit cells, 14 unit cells in the 7 crystal systems, how they have arranged and what are the relation between their interfacial angles as well as the axial distances in this table column we are here. This is most important table column in the examination. From this table only most of the questions with different way, tricky questions also they are asking. So if you just practice this table, definitely you can bag that 4 marks in the competitive examination. Hope you understand. We will see in the next session with further developments in the solid state. Thank you very much.